Hello, Tom from Every Step Calculus, everystepphysics.com. This is a problem submitted by a student. How do you evaluate this line integral? And it's a line integral. The original formula is the integral of a function times dr, which is the derivative of the rt function here, and then c is the parameters are going through, which in this case is a curve. Trying to find the integral of this curve here. Index 8 to get to my menu. Scroll down here to line integrals, because that's what they are asking you to do in the problem, in your test or whatever, homework. So we're going to go down here to line integrals. I'm going to press enter, and we're going to choose number 6, I and J, because that's what they give you here. We're in I and J, okay? So you have to get used to that in my programs a little bit. You have to think a little bit in college. So I and J, we're going to choose number 6, and then in calculus 3, this is an M. This might be calculus 2 here because we're only dealing in X, Y, and IJ parameters, not X, Y, Z, and IJK parameters. So if it's calculus 2, then this is an M, which tells you that this whole function here is an M, and this is an N function before the J, okay? So enter the M function term before the I. Here's the term before the I, okay? And we're going to put that in. Now you're going to press alpha. That's the only thing you have to do in my program. Just press alpha, and then you can enter the 2 times x times y plus 1 here in the calculator here, okay? And then, so we did that. And then the N function here. And we're going to enter that, x squared plus 1, by pressing alpha first, and then putting that term into the calculator, okay? Now I've already done that in a simulator to save time, so you can see that it matches what they're talking about. The calculator always puts the xy terms before the constants, so it switched them around a little bit, but no big deal. That makes sense to us. And we're saying it's okay because you can change it in case you made a mistake in entering it. Are line segments given? No, they're not. A segment is xy point to another xy point, or xyz point to another xyz point, depending upon what they tell you in the problem. But no line segments, so we're going to say no. But they do mention I and J in the problem. Okay, so here's I and J. Where is it? Here's I and J. We're going to say yes to that, and we're going to enter the term before the I, which is T. Okay, so we'd enter alpha T normally. Alpha T. And then we're going to enter the term before the J. Well, here it is over here. Now this is a tricky problem because sine of pi over 2 is really 1, okay? So you can put that in here. You can enter sine of pi over 2 times t squared, just like it says here, but the calculator will assume that you're talking about sine of pi over 2 is really 1, so it's 1 times t squared. So if you enter that, it's just going to come up with t squared anyways. Okay, so here's the I and the J that they've entered here, and now we're going to put in the range. Range is 0 less or equal than t, and then less or equal than 1. Okay, so the lower limit is 0. You'd put alpha 0 in here, and then you put alpha 1, just in case they gave you something different here. But generally when you parameterize something in a problem like this, it's always 0 to 1. Okay. okay. So we say it's okay, so now we start to do the derivatives, etc. Here's the x term, which is t right here, and the derivative of that is 1. Here's y is t squared, and the derivative is 2t dt. Here's the original integral, and we're going to put all these what we found for x and y into the problem here, which we've done. I have to use quotation marks, so the calculator does that, but you're going to put parentheses around here, like for x you put parentheses around for t squared, okay, in your paper, etc. Then of course we multiply it out and condense it, and here's the real what you've entered here, and we're going to integrate the problem, which is here and there. You could do that really easy, couldn't you? I couldn't, but you could, over the range of 0 and 1. So we integrated this problem. Now at t equals 1, we compute it through there, and we get 7/2. At t equals 0, we compute it, gets a half. Upper minus lower, always in physics and calculus. Upper minus lower, which we've determined. And the answer is 3. Pretty neat, huh? EveryStepCalculus.com. Go to my site, buy my programs. They're only $40, and you'll pass calculus, and you don't have to study this stuff hours and hours and hours. I'm pretty good at line integrals right now because I've been doing it for 3 weeks. 25 years actually, but then cleaning it up here for 3 weeks for other problems, and almost all the problems I can find. So have a good one. I hope you pass calculus.